Hello, good day and welcome to my channel. Today we'll be looking at a polynomial problem. It says when f of x is equal to 5x cubed plus px squared minus qx plus 1 is divided by x minus 3 and x plus 2. The remainders are 163 and negative 17 respectively. Find the values of p and q and remainder when f of x is divided by 2x minus 3. Now, the first thing for us to do here, let's write the expression. F of x is equal to 5x cubed plus px squared minus qx plus 1. Now, the first thing for us to do is to look at this first term here, which is x minus 3. This is what the polynomial was used to divide. The polynomial was divided by this, and then we had the remainder 163. So for us to know what we are going to substitute into the polynomial, we are to equate this term to 0. So I'll have x minus 3 is equal to 0. And that will give us x is equal to, when this negative 3 comes to this side, becomes positive 3. So we are going to substitute this value of 3 into the expression, and then we equate it to the remainder according to the remainder theorem. So we are going to equate it to 163. So I can simply write it now as 5x cubed now. So in place of writing the x cube, I'm going to write the original expression. As you can see there, 5x cubed. So in place of the x, I'm going to put this value 3. So 3 cubed. And then plus px squared. That is p now. X is 3, so 3 squared. And then minus qx, which is 3. And then plus 1. And everything should be equal to 163, which is the remainder. So when we do this, we have to simplify further now so that we can obtain an equation in p and q. So 3 raised power 3 is 27. That is 3 multiplied by itself 3 times is going to give us 27. Then 27 multiplied by 5 will give us 135. And then plus 3 square is 9. So multiply by p, I have 9p. And then minus 3q, when 3 multiply the q there, and then plus 1. And that should be equal to 163. So I can simply leave the 9p minus 3q on the left hand side, and I take 163, which is already on the right hand side, and then this positive 135, if it comes to this side, it becomes negative 135, and then positive 1 as a constant term 2 comes to this side, becomes minus 1. So I have 9p minus 3q is equal to 163 minus 135 minus 1 will give me 27. So if you check, we can express this in its lowest term because we can divide each of the term here by 3 as a factor. So 9 divided by 3, that will give us 3p. 9 divided by 3, that will give us 3p. And then 3 divided by 3, that will give us 1. So I write it as q, 1q, which is empty as q, and is equals to 27 divided by 3, that will give us 9. So I can call this equation 1. I can call that equation 1. And then let's go to the other term now. Don't forget, we are told that it is divided by two terms there. So looking at the question again, the first one says we are dividing by x minus 3, and then this one says we are dividing by x plus 2. And when we divide by x plus 2, the remainder is negative 17. So we are going to substitute the value that we obtain here. When we equate it to 0, the value that we obtain, we substitute into the expression, and then we are going to equate it to the remainder, negative 17. So let us bring down that value first. So I have it as x plus 2. Don't forget, this is the second term used in the division, and we equate it to 0, and that will give us x is equal to, when this positive 2 goes to that side, it becomes negative 2. So we're going to substitute the value of negative 2 for x in the original expression. So don't forget, the original expression is 5x cubed. So I'm going to say 5 negative 2. Now in place of x, I'm going to put negative 2 cube. Then plus px square. So px square, I'm going to put negative 2 for the x square. And then I square it, negative 2 for x. And then minus qx. Q multiplied by negative 2, that is qx. And then plus 1. And then it should be equal to the remainder, which is negative 17 from the question. The remainder is negative 17 when we divide by x minus 2. So now I'm going to simplify this so that I can obtain another equation. So negative 2 raised to the power 3 will give us negative 8. Multiplied by 5 will be negative 40. And then negative 2 raised to the power 2 is positive 4. Positive 4 multiplied by p will give me positive 4p. And then negative q multiplied by negative 2 will become positive 2q. And that will be equal to, plus 1. And that will be equal to negative 17. So we can simplify further now. If I leave this 4p on this side, 4p plus 2q, and then negative 17. When this negative 40 goes to that side, it becomes positive 40. And then this positive 1 comes to this side, it becomes negative 1. So I now have 4p plus 2q is equal to this negative 17 plus 40 minus 1 will give us 22. So if you check, we can also express this in its lowest term, because each term here can be divided by 2. So 4 divided by 2 will give us 2p, plus 2 divided by 2 is 1q, and so I can simply write it as q is equal to 22 divided by 2 will give us 11. And then I can call this equation 2. Don't forget our equation 1. Let me bring down the equation 1. This is equation 1 that says 3p minus q is equal to 9. So let me bring it here to use it to solve them simultaneously. So I have the equation 1, which is 3p, then minus q is equal to 9. Don't forget, this is our equation 1 obtained earlier. So if you check, the coefficient of q here is 1, but with different signs. So for us to eliminate q, we simply add the two equations. So I can simply add them. Let me rule a line now. So I say 2p plus 3p, because we are adding the two equations in order to eliminate q. We are solving them simultaneously now using elimination method. So 2p plus 3p will give us 5p. And then positive q added to negative q is 0. So q has been eliminated. And that will be equal to 11 plus 9 is 20. So we can divide both sides by 5. This divided by 5. And then what would that give me? That will give me p. Because 5 divided by 5 will cancel 5. So I have p is equal to 20. sorry, 5 to be 20 divided by 5, because I'm dividing both sides by 5. So P 5 cancel 5, and then 20 divided by 5 will give me 4. So I now finally have P is equal to 4. Then we can take any of the two equations to obtain the value of Q. So let me take equation 1. In equation 1, I have 3P minus Q is equals to 9. So I can simply write 3P, but P is 4. So 3P, in place of the P, I'm going to write 4. And then minus Q, which is what I'm looking for, and that will be equal to 9 on the right hand side. So I can simply say 12 now. I bring this 9 to this side, becomes minus 3, and then it's equal to, I take negative Q to that side, becomes positive Q. So I can decide to write, instead of writing this is equal to this, I can decide to write this is equal to this. So I can decide to write the Q first and say it's equal to 12 minus 9. Sorry, this is 9, not 3. This 9 comes to this, I become negative 9. So 12 minus 9 will give us 3. So therefore, I can conclude now with this A part of the question and say, therefore, P is equal to 4, as we have obtained for P, and Q is equal to 3. So these are the two solutions for P and Q. So can I go to question B part? Let's look at the B part of the question. It says we should find the remainder when f of x is divided by 2x minus 3. So 2x minus 3 when it is divided by that value. So I'm going to write B now. That is question B. 2x minus 3. We are saying when it is divided by 2x minus 3. So we simply equate this 2x minus 3 to 0. And then we solve and obtain the value of x. So I have 2x is equal to 3. When this negative goes with that, I become positive 3. And then when we divide both sides by 2, it gives me x is equal to 3 over 2. So I'm going back to the expression now. Anywhere I see x, I'm going to substitute 3 over 2 in the expression. That will help me to obtain the remainder. So please, if you are enjoying this video, please subscribe to this channel so that you can get more detailed video explanations like this. So now we come back to the expression. Don't forget the expression as given to us there is 5x cubed plus px squared minus qx plus 1. That is the original expression. And then we just obtain from here, we obtain the value of x as 3 over 2. So I'm going to take this expression and substitute 3 over 2 for x so that it will help me to get the remainder. So I'm going to say 5 now. Don't forget the original expression is 5. It says x cubed. So I'm going to say 3 over 2. That's the value that we obtain for x, all cubed. And then plus p x square, sorry, x is 3 over 2, that is 3 over 2 square, and then minus qx, q into 3 over 2, and then plus 1. So we simplify this, whatever it gives to us, that becomes the remainder. So this becomes 5, and then 3 over 2 raised to power 3 means 3 raised to power 3, which is 27. And then all over 2, this power will also affect 2 down here. 2 raised to power 3 is 8. And then plus, don't forget p that we obtained is 4 from the first part of the question. P is 4. And then 3 square is 9. over 2 square is 4. And then minus q, we obtain q as 3. And then multiply by 3 over 2. And then plus 1. So 5 multiplied by 27 is going to give us 135. So I have 135 all divided by 8. That is the 8 that I have here. Then plus 4, we cancel 4, and then we are left with 9 here. And then minus 3 multiplied by 3 is 9, I mean. Then all over 2, 9 over 2, and then plus this one, which is 1. And then from there now, we can obtain the LCM. The LCM of everything here is 8. The LCM is 8. So we can continue with that now and write the 8 as our LCM. 8 divided by 8 is 1. Multiplied by 135 is 135. Then plus, this is like 9 over 1. 8 divided by 1 is 8. Multiplied by 9, that is 72. And then minus 8 divided by 2 is 4. 4 multiplied by 9 is 36. And then plus, this is like 1 over 1. 8 divided by 8 is 8. Multiplied by 1 is 8. And then that will move further to give us 135 added to 72 minus 36 plus 8. Everything here will give us 179. 179. Then all divided by the denominator that we have here, which is 8. And this will be the remainder. So when that expression is divided by 2x minus 3, the remainder is 179 over 8 as our final answer. So please subscribe to this channel so that I can get more detailed videos like this. Thank you for watching, and see you in the next video.